Hi, good afternoon, everyone. My name is Sharad Kumar. I'm the field CTO of Data at Qlik. So now let's move to the second trend, which is about open table-based lakehouses. So let's talk a little bit how people build their data architecture in the last few years. So think of it: most customers go into Snowflake, go into Databricks, go into BigQuery. And what you're doing is when you move your data into these platforms, so think of it, they hold your data captive now. Once it's in their platform, largely you have to use their compute on the data because the data is in there. If I put the data in Snowflake, I got to use the data. If I need to transform the data, I got to use Snowflake compute because the data is sitting there. Right? I'm not going to take it out every time and then load it back again. Right? So what happened was customers lost control of their data. Once they pushed it into one of these platforms, it was captive within that platform. So the new trend emerging is this new format, table format, like Delta. Delta is an example, which was created by Databricks, but they made it open source. Then the two other competing standards over the last few years have been Hudi as well as Apache Iceberg. And what these things do is really an abstraction layer over file format. So we all know for years we've been using Parquet, kind of almost like a de facto standard for storing analytic data. And even in Hadoop world, we had Parquet. But what happened is with just Parquet, it does not have ACID properties. We cannot just update the data, right? It doesn't have that integrity in it. So what this table format is providing that layer of abstraction and providing these kinds of capability like transactional consistency. So you can act and at scale. So you can treat these files almost like databases. I can do update, I could read, I can snapshot. They behave like database. So these new standards have been coming up, and customers are looking to build their lakehouses on this format. Right now, and then different type of compute engines work on this format, right? And these are the three kind of components. Now, what that does is two things. One, customer since this is not locked in, so it's almost like think of it, I've unbundled the compute from the data. So now as a customer, I have more control over my data. So almost I control this and I can pick the compute engine of my choice. So if I look kind of graphically, what it means is, think of it, if I have data, it's like the USB stick of data now. So what happened when we evolved to USB? I could take my data. It had a standard interface, USB 2, USB 3, and I could plug into different computers because all computers supported that standard. So think of that same analogy now. If I have my data in this open table format, let's say an Iceberg, I can pick any compute engine to read and write on that data. Now what that gives me is great flexibility to pick the right engine for the right job. Earlier, if I load everything into Snowflake, I got to use all their compute. So now if let's say I bring data in and I keep it in Iceberg format, if I just have an ad hoc query where performance of the query is not that critical, I may use, let's say, a Trino engine to query that data. If I have a warehousing use case, a lot of concurrent user, I can choose to use a Snowflake engine for it. If I have a machine learning use case, I can use a Spark engine for it. So the data one, I'm not copying the data again and again. I can pick the right engine for the right job. And what ultimately does is it flattens the cost curve. Because every customer we talk to in the cloud world, they're all worried about costs going high, right? Warehouse costs are going through the roof, right? Snowflake, every customer, Snowflake costs are going up, I can't control. So this is a great method. One, it gives data ownership, choice of compute, and what Drive does is in the end drives your cost down.
Do you have any kind of a ROI calculator or a way to help people gauge what that benefit might look like?
Yeah, so not yet, right? Not yet. So this is kind of the early stage of evolving trend, but every customer we are talking to, they're very interested in saying, okay, I want to look at Iceberg, I want to start storing data in Iceberg formats. because it gives you that flexibility, your ownership, and Iceberg really, and this sits on object storage, right? So typically it will be, if I have Iceberg, if I'm in AWS, it'll sit on my S3. And actually, if you look at the keynote, I was listening to the keynote yesterday, AWS announced capability when you store this Iceberg, they have created a special type of bucket for it now. You put Iceberg where they will handle optimization of that under the covers. So a lot of new capabilities are coming out in every platform. So like I said, till now there were really three competing standards, and in the end there were really, last couple of years, two main competing standards, because Hudi is there but not that prevalent. So it's really the Iceberg community and the Delta community, and Delta community largely driven by Databricks. But if you just look at this simple chart of all these different kind of engines out there, everything from Spark, Flink, Snowflake, Databricks, you will see Iceberg has a much broader support across all these engines from a read-write perspective. So it's kind of become known that Iceberg has really won the war of open table formats. And if you look at the last bit of information was about a few months back, Databricks acquired this company Tabular for $1 billion, and they were the original creators of Apache Iceberg. So I was at the keynote address at the Databricks summit in Chicago a couple of weeks back, and there they were talking about, and eventually these two formats are going to converge. Because now Databricks has ownership of all the architects, people who actually wrote the Iceberg, and they have Delta, and there are differences between the two. But now they're just slowly bringing them together. So my thinking is that probably in the next year or so, these two formats will converge. Right now what happens is, and if you look at all of these platform vendors, they all support Iceberg. Snowflake supports Iceberg. Now Databricks supports Iceberg, but in a different way. Internally, it translates Delta to Iceberg. So it's not really true support. They have this layer called Uniform, which translates Delta to Iceberg and Iceberg to Delta, and that's how they make it look like support. But all the other tools like Salesforce and Google BigQuery, they all support Iceberg. Right? Some of the new architecture that our customers are looking to build is all based on this Iceberg-based open table form. And you can see the kind of the usage curve of these table formats. Now, so what does it mean to different type of things, right? So let's say now I'm bringing in data from different sources. If I'm doing data ingestion, I gotta write data in the Iceberg format. I need to take, and that's a bronze layer like we're talking about. If I'm going from bronze to a silver layer, I would have to transform the data from Iceberg to Iceberg. I may have to do data PII detection on Iceberg data. I may have to do quality check on Iceberg data. I may have different type of usage pattern, like I was telling you. You could have ad hoc queries coming in for Iceberg data. You could have a warehouse query for Iceberg data. You have machine learning type workloads. You have generative AI type workloads. So what we are going to see is a lot of different type of compute. So the war, in my mind, is going to shift to the compute layer now, right? Because if the data layer is always going to be this Iceberg format, customers are going to be, okay, these are different type of workloads. Which engine should I use for these types of workload? And we are also working right now, we're coming up with a strategy on what would Qlik support. So we are looking to see if some of these engines we are going to support, right? Because we already do data quality, we do PII detection, we do transformation, but all the compute for that is currently pushed down into the platforms. But if the data format becomes open, an Iceberg, it opens up the door for a lot of different type of compute. And the choice, our customers could pick different type of compute engines for each of these types of workloads.
When you talk about PII detection, are you including other types of data classification?
Yeah. It's a very broad term I'm using. It's really, so we are putting into a tool which is really using the semantics of the data.
Yeah.
So it could be mapped to, this is sensitive data. And typically what you do is you have different kind of tiers, right?
Yep.
So you have public data, you have internal data, sensitive data, yeah. And then you could, based on your semantics, detecting the semantics and mapping it to one of those tiers.
Okay.
So generically, I'm calling it PII, but different.
Kind of full data classification.
Yeah.
Sounds like.
Yeah, exactly.
Thank you.
Yeah. Now, another thing that's kind of interesting to think about is in the world of these open table formats, there's a very important component, which is a catalog. Now, this catalog is kind of a misnomer, right? The catalogs that we all understand are really, I call them passive metadata in the sense that they collect, and you don't need that catalog to process the data. Whereas in this environment, catalog is the mediator. So if I want to read or write the previous picture, I have to go through the catalog layer. If I want to read an iceberg table, I need to first go to the catalog and then get the pointer to the right table, so read. Same thing if I want to update it, I got to get the pointer to the current version, I got to update it, then I got to update the catalog. So catalog has become an integral component of, you cannot have really iceberg environment without a catalog, right? So there are different levels of catalog. So there are multiple catalogs out there. So now the iceberg format has converged, but still multiple catalogs. So Unity catalog, Databricks open sourced it. Snowflake has open sourced Polaris. In the AWS environment, there's a Qlik catalog. So there are multiple catalogs right now. And a lot of these engines are beginning to work with multiple catalogs. Okay. So if you look at, in summary, if you look at what completes the picture is, you have a storage layer, which is an object store like an S3. On top of that, you have files, right? So what Iceberg does is there are two types of files: the data files, which are stored in Parquet format, and metadata files, which are stored in JSON format. So those two together form the bundle. You require a catalog where all of these are indexed. So the catalog holds the keys to where the data file is, where the metadata file is, which is the latest data file, and all this stuff. And then you have engines that compute on it. So engines have to work with the catalog, and they directly read, write the data and metadata files on an object store. Right? So let's talk a little bit about, okay, what are we doing? So this is kind of early stage. So right now, currently we support Iceberg within our Talent product, right? So what happens in Talent Studio, you go, let's say, design your job, and you have data coming in, your source data gets landed, let's say today in a Parquet format on S3. So what we allow you to do is go here and design a job, and we have connectors which can read and write Iceberg format. So that means now I can define a job that executes, because you need a compute engine. Remember we talked about, you need a compute engine. So we can use any Spark compute engine. And this Spark compute engine then can take data from landing and write into Iceberg. So basically, essentially, using this, we can convert Parquet data into Iceberg data. And then we can take Iceberg data, transform it, and create new Iceberg data. So now we can enable our customers to start building these lake houses based on Iceberg. And now to query this, they can pick any of the tool, and we are integrated with AWS Qlik catalog today, and we have a number of other catalog integrations coming, right? So this is available today in a Talent portfolio, right? Be able to read from Iceberg, be able to write from Iceberg, and you can build any kind of design complex integration logic and mappings to transform the data from Iceberg to Iceberg, right? So if you look at this, automatically covers multiple use cases I showed earlier, right? We can take data, we can transform, we can make source data available as Iceberg, we can transform Iceberg data. In here, when you're defining the Talent Studio job, you can put data quality checks in there, so we can actually, as part of this pipeline, improve the quality of the data, right? We can detect sensitive information in there. So a lot of that stuff we can do through this on Iceberg data now with the talent portfolio. This one I'm going to keep short because next month we have some interesting announcements coming out on the roadmap of this. So right now, I'm not going to cover too much detail, but future phases of Iceberg support. We are building support for Snowflake managed Iceberg. So I can bring a Iceberg drop data and put it into a Snowflake envelope. So our customers can still use Snowflake capability to read, write on the data, right? But it's stored at Iceberg as opposed to into the Snowflake format, right? We are going to provide ultimately, this is a new capability we're all designing, FinOps-based optimization. So think of it now. We talked about different types of compute engines, and a little bit you were talking about, I think, ROI. So if you have different choice of compute engine, we want to get to a point where the customer doesn't have to figure out which engine should I use. Based on cost, performance, and the statistics, we will be able to recommend and even route it to the right engine. So kind of think of the vision is you design transformation and you could execute that on the right engine, which gives you the best cost performance at that point. So become more dynamic environment in terms of engine selection, things like Iceberg optimization, right? Iceberg supports in all our other tools like Qlik Replicate, Qlik Talent Cloud. So basically, we're beginning to build an entire roadmap around Iceberg, which we'll talk publicly fairly soon, right? For more capability. So again, I'm going to do a quick demo.
This demo showcases some of Qlik's features around data processing in Apache Iceberg. We are using AWS Glue as the catalog, with our metadata and data files stored in S3 buckets. I have created a database called Iceberg Catalog, which contains two tables. We will turn our attention to the customer CRM table. It's a mapping between the table and the object storage. Taking a quick look at the table schema, it's pretty straightforward. And we can also preview the JSON metadata files in the S3 bucket, which offers us scalable storage. And we can see here that our data is stored as Parquet files. We have 180 small files. To allow us to process the data, we have three main Iceberg components released for Studio. The catalog component allows us to connect to our catalog, configured with the connection properties. In this example, our first pipeline reads from Iceberg. We have added a sampling component, so we display a subset of our 5 million records, and the implementation, as straightforward as you would expect from a Qlik Talent Studio job, basically source to target in a few clicks. The second part of the pipeline allows us to write records to Iceberg. We are generating new rows using a row generator for demonstration purposes, and then we replicate the pipeline so we can move the records to the customer CRM table and also the feedback window at the bottom of the screen. We have some options on the action we take on our table. We can create a new table or replace an existing table if required. We can append new data or replace existing data identified by a primary key. When we compile the job, the required components are pulled into a Spark cluster that is provided for testing with Studio and run locally on this machine. After completion of the job, you will see that we have written 10 new records to the table. In production, you have the choice of a wide variety of different distributions, such as EMR to handle the processing at scale. Choices for connectivity include Hive and Hadoop, with the custom option allowing you the freedom to configure as you choose. We can see the updated synchronization date with the catalog, and also the new Parquet files added to storage too. The integration takes care of all the back-end management of the files, tables, and also the catalog. Customers can access these new tables directly, or even use features like the external table support in Snowflake to access the catalog as they would a native table, which then allows us to promote this table within the data products catalog in Qlik.
So that demonstrated our capability in the Qlik in the Talent Studio. How again, drag and drop, you can bring Iceberg components, you can connect to different types of types of catalog, and you start to build transformations, right? In this case, we showed how new data coming in, right? We updated Iceberg tables, right? And we could read from Iceberg, transform, and put. So it brings new set of capabilities to our customer to start building out Iceberg-based data lakes.